In this video, we'll be analyzing distributions in terms of percentiles, quartiles, using IQR, z-scores, and box plots to identify outliers. A percentile is the value of variable at which a specific percentage of observations are below that value. So, for example, a number is at the 10th percentile where 10% of the values are below that number and 90% of the values are above that number. Another example is, let's say in the US, 90 percentile annual income is $350,000, which means that 90% of the people make less than $350,000 and only 10% makes more than $350,000 a year. Let's see how we determine the 85th percentile for the home sales price. So we have 12 data points or 12 observations. So we first arrange the data in ascending order from the smallest price to the highest price. So then the second step, we compute the 85 percentiles position. So 85 percentile divided by 100 multiply the number of the observations, which is 12 plus 1, then we come to 11.05. So keep in mind that this 11.05 is only the position, not the value. So it's not the home price at the 85 percentile. So how do we find the home price value at the 85 percentile? So we know that with the 11.05 position, this value must be between the 11th position and the 12th position, just a little bit, like 5% over the 11th position. So we find the value in the 11th position, which is 298,000, and the value in the 12th position, which is $456,250. So the range between 11 and 12 position is 456,250 minus 298,000. Now we can calculate at the 85th percentile, the home value should be 298,000 plus 0.05 multiply this range. So the result is 305,912.50. So the home price at the 85 percentile is $305,912.50. Quartile is when we divide the data into 4 equal parts. Each part contains approximately 25% of the observations. And then we can use the division points to specify quartiles. So for example, first quartile is the 25 percentile. Second quartile is the 50th percentile. It's also the median. Third quartile is the 75 percentile. So the difference between the third and the first quartile is often referred to as the interquartile range, or IQR for short. Another way to analyze distribution is to use a z-score. Z-score basically tells you how many standard deviations each value is away from the mean. So it shows you the deviation from the mean in terms of standard deviation. So z-score equal to 1 is 1 standard deviation from the mean. Z-score equal to 2 is the 2 standard deviation from the mean, and z-score equal to 3 is 3 standard deviation from the mean. And when you convert your values to z-score, we often call the process standardization. So the z-score can be interpreted as the number of standard deviation xi is from the mean x bar. So this is the formula for z-score. For each value in the dataset, to calculate the z-score, you basically have to subtract it from the mean and then divide it by the standard deviation. And then you get a number which we call z-score. So for example, here we have 5 class size values again. We already know the mean of the sample is 44, and the standard deviation of the sample is 8. So to get the z-score for each value, you just subtract the mean from each of the value and then divide the result by the standard deviation. So the first class size is 46. Minus the mean 44, the result is 2. Divided the 2 by the standard deviation 8, the result is 0.25. So 0.25 is the z-score for the first observation, which is 46. So this process is also called transformation or standardization. Now each value is transformed to a new value, a z-score. So two things z-scores tells you. First, it tells you whether the value is to the right or the left of the mean. A positive z-score indicates the value is greater than the mean, while a negative z-score means the value is less than the mean. And then it also tells you how far it is from the mean. So this one is 0.25 standard deviation from the mean, just by a little bit. It's not too bad. When it's way apart from the mean, that's when we may call it an outlier, and we may want to remove it. Next, I'll show you how to calculate this in Excel. So here we have 12 home sales prices. To calculate the z-score for each value, we use an Excel function called standardize. In this formula, we need to input first the value we're going to calculate z-score for, and then the mean, and lastly the standard deviation. So we have the negative 0.68 z-score. So this means that this value is lower than the mean by 0.68 standard deviation. So before we copy this formula to the rest of the observations, we need to make the address of these two cells absolute, because we don't want them to change. The mean and the standard deviation shouldn't change. So we can use F4 or just manually add a $sign to it. You can use F4 on either Windows or Mac machines. And then press enter. Now we can copy by double click on the cell's corner or just drag and drop. So we can see that the z-score ranges from negative 1 point something to positive 2.48, but it's within a nice range. We say that usually it's between negative 3 and positive 3. So I'll talk about this range a little bit more. When the distribution of data shows a symmetric bell-shaped normal distribution, we can use empirical rule to determine the percentage of data values that are within specific number of standard deviation of the mean. So for data having a bell-shaped distribution, we say that approximately 68% of the data values will be within one standard deviation, approximately 95% of the data values will be within 2 standard deviations, and almost all the data values will be within 3 standard deviations. And those that are outside the 3 standard deviations, from outside negative 3 or less than negative 3 or more than positive 3 standard deviations, we usually call them the outliers, and we usually want to remove them. So for example, the height of the adult males in the US has a bell-shaped distribution with a mean of approximately 69.5 inches and standard deviation of approximately 3 inches. So using the empirical rule, we can draw the conclusion that approximately 68% of the adult males in the US have heights between 69.5 minus 3 equals 66.5, and 69.5 plus 3 equals to 72.5 inches. And approximately 95% of the adult males in the US have a height between 63.5 and 75.5 inches. So almost all the adult males in the US has height between 60.5 and 78.5 inches. So basically it tells you that if a z-score is larger than 3 or smaller than negative 3, that value is most likely an outlier, because empirical rules, most values should be between negative 3 and positive 3 standard deviation from the mean. So here's a normal standard distribution look like graphically. It should look like a bell curve, and in the middle is the z-score equal to 0. That is to say, it's the mean in the middle. Outliers are extreme values in the data set. An outlier may be data value that has been incorrectly recorded. If so, it can be corrected before further analysis. It may also be from an observation that doesn't belong to the population we're studying and was incorrectly included in the dataset. If so, it can be also removed. It may be an unusual data value that has been recorded correctly and is a member of the population we're studying. So in such case, the observation should remain. And we can identify outliers using the standardized values, that is z-scores. If a data value is outside the z-score range, which is less than -3 or greater than +3 standard deviation from the mean, then it would be an outlier and such data value will be reviewed. We can also use a box plot to identify outliers. A box plot is a graphical summary of the distribution data developed from the quartiles from a data set. So for example, a box is drawn with both ends of the box located at the first and the third quartiles. And for the home price sales data, Q1 is $139,000 and Q3 is $250,625. So this box contains the middle 50% of the data. A vertical line is drawn in the box at the location of the median, which is $203,750 for the home sale data. So what is between the Q1 and Q3? We talk about that's the IQR. So IQR equal to Q3 minus Q1. So then we have the limit of 139,000 minus the 1.5 times the IQR, which is one difference between the Q1 and Q3, which is $117,625. So that equals to negative $37,437.50 and $256,625 plus 1.5 times the IQR, which is $433,062.50. So data outside this limit are called the outliers. For example, this one. So again, this dashed lines are called the whisker. It ends at 1.5 IQR below Q1, and the upper limit is 1.5 IQR above the Q3. Any observation outside this range of the whiskers could be considered an outlier. Next, let me show you how to do this in Excel. So here I have 12 home sale prices. So to create a box plot, I highlight the data range of the selling prices. And then I'm using Mac version of Excel. So for me, it's under the insert. And under this chart look like a histogram. Click on the down arrow and you see histogram, box, whisker, and we select the box and whisker. So we have a box plot or whisker plot that's showing the data range. So we have the X here is the mean. The line in the middle is the median. And this is Q1, which is 25 percentile, and this is Q3, which is 75 percentile. And the difference between the two, or the blue box, is the IQR. And this is the maximum of the upper limit of the whisker, or the maximum. This is the lower limit of the whisker, which is the minimum. And outside the whisker range, we see one observation that can be considered as the outlier. The value is $456,250, which is our number 12 home sale price. And so it's way outside the whisker range. We can consider that as the outlier and remove it before we process the data further. Box plots is a standardized way of displaying the distribution of data based upon 5-number summary: the minimum, the first quartile, median, the third quartile, and the maximum. So we see the middle is the median. This is the Q1 or 25th percentile. This is Q3 or 75 percentile. And in between them is the interquartile range or IQR. Q1 minus 1.5 times IQR, that's the minimum and the lower end of the whisker. And Q3 plus 1.5 times IQR is the maximum with the upper limit of the whisker. And outside the whiskers range is the outliers. And we see 4 outliers here. We can compare box plot with a probability density or like a bell-shaped distribution chart so that you can see the statistic meaning of it. So the box or IQR is coordinated with 50% of the data, and adding the whiskers we get the 99.3% of the data, and the outliers are only 0.7%. We can also create box plots for multiple columns. For example, I have the home sale price for 5 different counties. So I can highlight all the sales data and go to Insert and Box Plot. So we can see that all 5 columns are including in this box plot. And we can add more labels to it so we know what is which. So under the legend, let's put it to the right. So we can see that the most expensive house appeared to be in the shady side, and the cheapest house is in the Hamilton. We can also see here the median home selling price in Gorton is about the same as the median home selling price in Irvine. However, home sales price in Irvine has much greater variability versus Gorton's has very close proximity to each other. Homes appear to be selling in Irvine for many different prices from very low to very high. Gorton is the only location considered it has an outlier here because, but note that most homes sell for very similar prices in Gorton. So the selling price doesn't have to be too far from the median to be considered as an outlier. It's based upon the whole range of the majority of the data points within that county.